Hello, astronomy and meteorology students. It's Mr. Johnson here. I want to give you some notes today over the basics of the atmosphere. You have already watched a few ed puzzles over a couple things like the layers of the atmosphere and barometric pressure and what weather is compared to climate. Today, what I want to do is I want to give you an overview. I'm going to be moving fairly fast because some of this will be review from the videos, but I'd like to give you notes anyway. Ultimately, I want to be able to move on and actually tell you how to use some of this information. So again, this is going to be a basics of the atmosphere in terms of its characteristics so that we can move on and actually apply it. If you need to get notes, please do that now. You can always pause and rewatch this video if you need. Obviously, notes can be on paper or Chromebook. It doesn't matter to me. It's totally up to you. Here we go. To start off with, when we talk about our atmosphere in the troposphere, tropos means change. And so when we say tropos, really we're talking about a change in weather. So what weather really boils down to has to do with the general conditions in an area, the general conditions of the atmosphere in that area. And there are a whole bunch of different characteristics that the atmosphere can have that we can measure. So things like temperature, wind speed, wind direction, how much moisture is in the air, what the air pressure is, how much moisture is in the air compared to how much there could be. And then we can actually even make things more complicated. We can combine some of these. So if you've ever heard of something like, the heat index, that's a combination of temperature and moisture in the air, but we'll get more to that later. And the thing with weather is it can and does change very often. And we know that really well in South Dakota here. It can be really nice, and in a matter of seemingly hours, it can be completely different. And so I want you to think right now, what's the weather like? If you were to walk outside, how would you describe it? Is it warm? Is it cool? Is it windy? Where is the wind coming from? Does it feel humid? Is it sunny? Is it cloudy? What's going on? There's a whole bunch of different things. Let's compare that to climate. And again, I know you've watched a couple ed puzzles on that, and if you haven't, then just a friendly reminder to go do that. The difference between weather and climate is that climate is an average of those conditions over something like 30 years worth of time. It's a really long time. So whatever that weather is that you just thought about when I asked you that question a moment ago, that's not climate. Climate isn't a day-to-day process. So if somebody ever says something about climate change not being real because it's cold or warm out or whatever they say, well, they're not really understanding what that means. And hopefully we'll have some time this semester, although I don't know if we will, to talk about climate change. But anyway, climate is long-term weather conditions on average. You have to average them out over a very long time. So let's talk about the properties of the atmosphere. There are really three that we're going to discuss, and it's going to be difficult for me today to isolate any one of those without talking about the other ones, but I'm going to do my best. We'll talk about air pressure, temperature, and humidity. So let's dive in. The properties of the atmosphere. The first one we're going to talk about pressure. The atmosphere has mass. It's made of atoms. There's all sorts of different atoms. The leading element in our atmosphere is nitrogen. And all things with mass are affected by gravity. And so we have gravitational pull of the Earth on all of that mass, and that creates pressure. Now, we can demonstrate this a whole bunch of different ways, and if we were in class, we probably would do some of these. So we could demonstrate it by filling a balloon with air, and we could measure its weight before and after it has air in it. We could even balance two balloons on kind of a teeter-totter and slowly deflate one, and we would see that the teeter-totter would tip toward the still-filled balloon. There's a really fun one that caused me to break a whole bunch of rulers one year by accident. If you take a piece of paper, you can use a newspaper or whatever you want, spread just one sheet out. It's got to be kind of big. Spread it out over a ruler with right at the edge, and the ruler has to be sticking out. Maybe a third of the ruler or a fourth of the ruler has to be sticking out over the edge of the paper or of the edge of the desk. Try and kind of slap that ruler, and you'll find that the air pushing down on the paper will stop you from being able to lift that paper up. Again, if you push down on the ruler, just apply direct continual force, then obviously you'll be able to lift it up. But a quick kind of slap, that ruler is not able to push the air off of the paper that's above the ruler. The majority of the mass of the atmosphere is within 32 kilometers of the Earth's surface, and the pressure of all of that atmospheric weight pushes down on the Earth. Or excuse me, all of that atmospheric mass is pushing down, and so at the Earth's surface, the air pressure is the greatest. And as you move away, that air pressure becomes less because the air becomes less dense. The air pressure is directly related to that density. The long story short, when you're close to the Earth's surface, there's more atmosphere pushing down, so there's greater air pressure. As you get higher in elevation or in altitude, you find that there's thinner air, so there's less pressure of that air since it's less dense. This is why they pressurize air cabins in airplanes. This is why people, when they hike up in high mountains, have to get acclimated to it, or they might get altitude sickness. And places like Mount Everest, most people use some sort of oxygen because it's so thin and the air is really, really almost light feeling. I've been up in the mountains, obviously not Mount Everest, but 14,000 feet, and it feels very crisp and light because there's less pressure up there. As you increase in altitude, there's a decrease in pressure. We measure atmosphere. We measure pressure in a couple ways, but usually we measure it in millibars. It really has to do with how much weight of the atmosphere is pushing down on a given surface. We measure this using a barometer. A barometer is a tool that can be used to measure that pressure. Now, sometimes people will use barometers or a form of a barometer to figure out how high up in the sky they are. They call that an altimeter, because an altimeter measuring altitude, as you go up in altitude, what happens? Well, the air pressure decreases. So as that barometer would change, it would be showing that there is less air pressure, and that's directly correlated to height. And by the way, the atmospheric pressure, that's pretty much not a steady decrease, but it's a continual decrease from the Earth's surface up into the exosphere. Let's talk about the two types of ways we can measure it. There's a liquid barometer and there is an aneroid barometer. The liquid barometer, as you watched in the Edpuzzle, basically it is working on the premise that the air pressure will push down on liquid. It used to be mercury, and that would then push that mercury up a tube. Well, that's the historical reason why atmospheric pressure is oftentimes measured in mmHg. That's millimeters of mercury. Now we typically use aneroid barometers. Taking a step back, liquid barometers no longer really use mercury. There's different substitutes for mercury now. An aneroid barometer, you've probably seen the thing in the bottom right. If you haven't, now you have. It's commonly used, and it doesn't contain mercury. In fact, it doesn't contain any liquid. That's what aneroid means. It's basically a sealed container that can change shape because of pressure being put on it. And as it changes pressure, it moves this little dial to a specified distance on a scale telling you what the air pressure is. Now, the reason we care about air pressure is because based on what happens to a barometer, you can get a sense for what type of air mass is moving in. We'll talk more about this later, but an air mass essentially is just a collection of air that has, for the most part, similar properties. So I know, for example, if I see certain clouds and the barometer changes, in a certain way, I have an indication, an idea of what sort of weather is coming in. So with this simple instrument, I can look at my surroundings and get an idea for what type of weather to expect. I'm not going to play this video. We'll move on. To kind of piggyback on the layers of the atmosphere, there is really no sharp pressure change as long as we're talking about pressure. Those layers in the atmosphere, really, the difference has to do with temperature. And I'm just going to kind of skip over this since you're already familiar with this. Let's move on to that temperature. So actually, I'm going to make that a different video. So I'm going to pause that and we'll move on. You can learn about temperature in the next video.